Okay, so it'll turn out that for the trig identities, there's actually several things that we can do with them. All right, there's tons and tons and tons of things and applications of trig identities. However, in section 1.4, we actually are going to use them to redo a problem that we've already done. If you go back to one of the first videos we cut in this module, we have actually answered all these questions, right? We've already found all these things, and at the beginning, we were grounded in our X, Y, R definition. So what I'm going to do now is I'm going to approach it using an identity. This takes skill, this takes practice, so make sure that you're playing around with it, right? Because you basically have to pull out, right? I think we had 1, 2, 6, 7, 8, 9, 10. We have 11 different identities at this point, right? Some of them are reciprocal, some of them are quotient, and some of them are Pythagorean. So which one I pull out depends again on what information do I have. So let's go ahead and do some work here, and you'll notice that sometimes it's even faster than the XYR definition, or vice versa. So you got two ways to do the same problem. So make sure, read the directions. Do I ask you to use an XYR definition, or am I asking you to use identities, and then show your work appropriately? So find sine theta given that the cosecant of theta is 3/2. Well, what I already know, right, is the good old-fashioned reciprocal. All right, we know that the sine of theta is 1 over cosecant of theta. So that means I'm going to take the fraction that I have, right, and rewrite it as 2/3. If you literally wanted to do the work, it would look like that, right? 1 divided by 3/2 means we're actually 1 times 2/3, giving us the 2/3. Or I just cut to the chase. We already know they're reciprocals. So if there's my ratio for cosecant, its reciprocal has to be the ratio for sine. And again, you kind of see the domain and the range in play, right? Notice the cosecant value is greater than 1, and the sine value is less than 1, like they should be. All right, so we're right on there. In terms of the quadrant, right, we're in quad 1, so everything's positive, so we're good to go. So the sine of theta is equal to 2/3 because of the reciprocal identity. So that might have been faster than our XYR. What about the next one? All right, well, we're asked to find the cosine given that the sine of theta is 1/4 and that theta is in quadrant 2. So our challenge here, right, there was a nice direct relationship between sine and cosecant. It was reciprocal. We got to kind of hunt around what identity relates cosine to sine. All right, and there's one famous one. The big one we want to use here is that the cosine squared plus the sine squared is equal to 1. And now all I have to do, very, very similar to your review quiz and review homework, I already know what the sine of theta is. So the cosine squared of theta is basically 1/4 squared equal to 1. And so now we have enough information to find the cosine of theta. We just use some math. So we have the cosine of squared theta is 1/16 equals 1. I effectively subtract 1/16 from one side to the other. So the cosine squared theta is 1 minus 1/16, right? So this is 16 over 16 and 1 over 16. So the cosine squared theta is 15 over 16. Of course, we don't want cosine squared, we just want cosine. So take the square root of both sides. Again, I've introduced a plus minus, and we have the square root of 15 upstairs. This breaks up into 2 square roots and 4 downstairs. So now, right, cosines as a function, one thing in, one thing out. Right now I have 2 possibilities, so we got to figure out, is it positive or negative? We're told that my angle's in quad number 2. And in that quadrant, we know that x is negative, which means that cosine also has to be negative. So our correct answer is the cosine of this theta is the square root of 15 over 4. All right, which I believe if you go back, right, is the same thing we found a few videos ago. All right, and I'll let you guys reference that. So 2 ways to do the same thing. I know this is a little different, it's a little abstract because we're using something that's new to you, right? A trig identity. We started with a trig identity, the right one, plugged in what I knew, solve for what's left. All right, so the next one, right? They want us to find the tangent of beta given that the sine of beta is -1/5 and beta is in quadrant 3. So now again we're trying to find something that relates tangent to my sine. Alright, and when we kind of put our thinking caps on, one of the things that students constantly say, well, I know that tangent of theta is sine over cosine. Number one, that's a true fact. But number two, I only know one of those values. This is what I'm trying to find, and I don't know what that is yet. Alright, so that is actually useless at the moment unless I can find my cosine value. Alright, so that might be, a way that we could potentially approach that. So how about we initially begin this? Let's begin this by using our cosine squared theta plus sine squared theta equals 1, almost like we did here, to get what I want. And then we just form the ratio. So we don't know what cosine is. We're trying to figure that out. And we've been told that the sine is -1/5, and we're going to square it. So this basically gives us cosine squared theta plus, I believe that's 1/25 equals 1. Subtracting 1/25 from both sides, right, we get that the cosine squared theta is equal to 1 minus 1 over 25. Alright, which means that cosine squared theta, this is 25 over 25, equals to 24 over 25. Taking a square root, introducing a plus minus, we get that the cosine of theta is plus or minus, right, we get the square root of 24 all over 5. This is 4 times 6, so we have the cosine of theta is equal to 2 square root to 6 all over 5. We are in quad 3, x is negative, so that means we're negative here. So we're not done. All I've done at this moment is found out what the cosine of theta is, right? The cosine of theta is -2 square root to 6 over 5. So now I can find tangent. By definition, by identity, we know that the tangent is cosine over sine. So this means I'm going to take my ratio -1/5 and divide it by my ratio -2 square root to 6 over 5. Of course, when I divide fractions, I'm actually multiplying by the reciprocal. The 5's will divide out. Negative divided by a negative is a positive, so we end up with 1 over 2 square root to 6. Of course, if I rationalize the denominator, right, we get the positive square root of 6, and I believe what we got is 12, which matches, right, the same thing we got. So the tangent, it's beta by the way, the tangent of beta for this situation is the square root of 6 over 12. And again, if you go back, you can see that we got the same thing. Although I would argue, and I would agree, right, that using the XYR definitions was a heck of a lot easier. Alright? So even though we think something's easier, that doesn't always mean that's the best way to do it. So you will use trig identities to do some of these problems, because it's the only way you're going to commit them to memory, get used to working with them, there's some good algebra skills here. Notice, we're balancing acts of adding, subtracting, square roots. A lot of good things to practice so that you're actually a better math student in the end. Alright, so please make sure you follow directions, even though it might seem real hard. Okay, the next one is a real animal, right? Because I actually have to find all the trig functions. And I agree, using the XYR definition was a piece of cake. So I'm going to actually stop this video and handle this in one all nice and fresh, since we're already 9 minutes in. So let me come back and finish that off using trig identities.